Hey everyone, welcome back to the channel. In this video, I'll show you my complete assembly language project, a gas leak detection system. But before we get into the wiring and code, let's start by building the enclosure using Servo board. For the casing, I'm using Servo board, a lightweight, durable plastic sheet that's perfect for assembly projects. Let's begin building the enclosure. First, I measured and cut 6 pieces, front, back, 2 sides, a bottom, and a top lid. Each piece was carefully marked and trimmed to size using a cutter. Be sure to sand the edges if needed for a smoother fit. The dimensions depend on your components, so make sure to allow space for your servo, fan, wires, and MQ2 sensor. Now that the pieces are cut, I'm gluing them together. Glue works great for Sintra, but you can also use plastic cement for stronger bonds. Make sure everything lines up nicely. This is going to house all our components neatly. Before sealing the top, mark where you'll need to drill or cut holes for the sensor, servo, LEDs, buttons, and wires. Once the box is dry, I drilled holes and slotted in the components, the MQ2 sensor, push buttons, fan, and LEDs. Once the box is dry, I drilled holes and slotted in the components, the MQ2 sensor, push buttons, fan, and LEDs. Servo board, the lightweight, durable plastic, that's perfect for housing my project components. Next, I arranged all the essential components inside the box, including the MQ2 gas sensor, servo motor, fan, buzzer, and the control circuit. I also created partitions inside to separate the sensor and actuator sections for better airflow and easier wiring management. After securing the components, I carefully wired everything up. I made sure to label and route the cables neatly to keep the setup clean and avoid interference. Here's the finished enclosure, compact and functional, with all parts mounted securely. Next, I'll show you how the 2 manual buttons control the system and how the MQ2 sensor automatically detects gas leaks to trigger alerts. The servo motor is also mounted securely so it can rotate freely through a vent slot. I also left a cutout at the back for USB power and programming access. With the case complete, let's now take a look at the electronics and how the entire system works both manually and automatically. Alright, now let me explain how this gas leak detection system actually works and what each component does. This is the MQ2 gas sensor, which detects the presence of flammable gases in the air like propane, methane, or LPG. The servo motor here is set to rotate between 0 and 180 degrees. At 0 degrees, it keeps the ventilation or valve closed. When gas is detected, it rotates to 180 degrees to open the vent or trigger a mechanical alert. This adds a physical response to the gas leak, helping ventilate the area automatically. The fan kicks in immediately when gas is detected. We use a buzzer and 2 LEDs to provide audible and visual alerts. When gas is detected or when the system is manually turned on with the first button, the buzzer sounds and the red LED lights up to warn danger. When the system is off or no gas is detected, the blue LED stays on, indicating that the system is in safe standby mode. There are 2 manual control buttons. Button 1, turn on safety mode. This manually activates the fan, buzzer, red LED, and rotates the servo to 180 degrees, just like an automatic gas leak alert. Button 2, reset, turn off safety mode. This turns off the fan, buzzer, and red LED, rotates the servo back to 0 degrees, and turns on the blue LED to show the system is safe. All these components are controlled by a microcontroller programmed in AVR assembly language, which reads the sensor input and button states to decide which outputs to activate. The program ensures automatic switching between safe and alert modes, while also allowing manual override for testing or emergencies. This setup makes the gas leak detector highly reliable, giving both automatic and manual control to ensure safety.